Okay, so just a reminder, you need absolute value bars when you divide an even exponent by an even root and get an odd exponent. So like up in here, 6 is an even exponent, 6 is an even root, 6 divided by 6 is 1, 1 is an odd exponent, so that's why we used absolute value. Okay, so now we're going to do this one. Now there's two separate problems inside the, it's 18. So again, this is 18, you guys, so that's 18. There's 64, so we got to take care of that, and then there's the quantity of 2y plus 1, two separate answers. So the first thing that we're going to do is we got to figure out what times itself 6 times. The same number 6 times gives us 64. If you don't know, you can go to your calculator, and remember I taught you. So if I'm using this one, what goes in first? The root or the number underneath the radical sign?
The root.
The root goes first, which in this case is 6. Second, caret key, this little key right here. And then 64, which is 2. If you have this calculator, this one, what goes in first? The root or the number underneath the radical? In this case, it is 64. You hit second, and then you're going to hit 6 because that's our root, and we should get the answer, and that's what we get. So now that takes care of the 64. Now we're going to take care of the 2y plus 1. 18 is my exponent, 6 is my root. I notice that they're both even. What is 18 divided by 6? 3. So even, and my answer is an odd. So I need to put absolute value symbols around that part. I don't need to do it over the 2. The 2 is fine, but the quantity of 2y plus 1, I need to work on. Any questions? Okay. When you have a problem that looks like this, I have a lot of kids that try to take the square root of each term, or they try to do a tree. But because it's all being either added or subtracted, you can't do it individually. The only time you can do it individually is when they're separated by multiplication. And in example 4, 64 times 2y plus 1, that's why this worked. This one does not work. But what does it look like? We probably have done this before, so what does it look like? It looks like a trinomial. So what can we do with trinomials? Starts with an F.
Factor.
Factor. So what is A? What is B? What is C? Okay. Now we're going to multiply A times 1, which is 36. And we're looking for two numbers that when we multiply, we get positive 36, but when we add them, we get negative 12. So what are two numbers you can multiply to get negative 12? Okay, so we found two numbers that when you multiply, you get positive 36. When you add them, you got negative 12. And we factored it. We used the grouping. And now, what do we notice about our final answer? Yep, 6x minus 1 and 6x minus 1, they're the same. So that means we can rewrite this problem. How many 6x's minus 1's do we have? So we're going to write 6x minus 1 squared. So I had to factor it so I could put it into parentheses. I'm going to tell you that most of the time when you get a trinomial, it's going to factor out to something that's squared. Okay, so answer time. I have a plus or minus because that just comes down with it. Whatever's in front of the radical comes down. 2, my exponent is even, my root is even, so 2 divided by 2 is 1. So that means I need, and that's my answer. What questions do you have? Okay. This really, I mean, you can write this down. We'll make this example 6 for you. What questions do you have? This is the last one that I kind of want to show you. It's a fraction. And some of my students, when they see a fraction, they're like, wait, I can't do this. Yes, you can. We're just going to separate it. We're going to the square root of 16 over the square root of 25. We can break it up. Well, what is the square root of 16? 4. What is the square root of 25? That's your answer. So if you notice the numerator and the denominator are both perfect squares, you just take the square root and you're done. Now tomorrow it might change up a little bit, but not by much. Okay? What other questions do you have?